This is a really good one. Find the probability that a randomly selected point, that a random point, will be in the shaded region. So remember, probability is the part divided by the whole. So the shaded region is going to be made up of a subtraction of two shapes, or a difference of two shapes. It's going to be the circle minus the hexagon. Beautiful hexagon. Ooh, that's a pentagon. Undo. Now it's a hexagon. And the whole is going to be the circle. So I like drawing two shapes, your circle and then your hexagon, so you can find the area of both. The circle we know has radius 14, so the area is going to be equal to pi r squared. The radius we know is 14. With the hexagon, again, you know your central angle is going to be 60. 360 divided by 6 gets you 60, so that means that the angle created by the radius and the apothem has to be 30. So we know the radius was 14. We're going from hypotenuse to short leg, so that means that the short leg has to be 7, which means the whole side has to be 14. And then the apothem is going to be 7 root 3, because we're going from the short leg to the long leg. So the area of the hexagon is going to equal 1/2 the apothem, which we know is 7 root 3, times the perimeter, which is going to be 14 times 6. Careful, everyone forgets to multiply by 6. So then what you can do is you can use that, find the area of the circle. That's going to be pi times 14 squared. Use these, type them into your calculator. I would suggest not rounding until the very end, and I would suggest making sure that you put parentheses around the numerator and around the denominator.